All right, BPC, this is the 3A notes where we're starting to look at the graphs of linear and exponential functions. What I want you to do to start is pause the video and look at these tables and decide if you think they are linear and exponential. All right, hopefully you're unpaused now and you notice that on both tables, the x values are just going plus 1, plus 1, plus 1. So what we can look at is what's happening with the y values. On my y values on this table, it's adding the same amount every time, which hopefully you remember from Algebra 1, Algebra 2. This is a linear function. I have a constant rate of change. Constant rate of change, which we say is the same slope every time. You're adding or subtracting the same number. Your functions for those are your very best friend y equals mx plus b, where your m is your rise over run, change in y over change in x. For this equation, that's 2 over 1. Your b is your y-intercept, and my y-intercept happens when x is 0. Now, over here, what I'm looking at is the fact that it's dividing by 2 each time. Well, that's exponential. That's when you multiply or divide by the same number. And for these, you will get the formula y equals ab to the x. Oops, let me actually write. This one was y equals mx plus d. Exponential are y equals ab to the x. Your a is your starting value, like b. It's kind of, well, actually, it is very much so when you don't have shifts, your y-intercept. So my a value here is 16. Your b value is what you multiply by. Not what you divide by, what you multiply by. So dividing by 2 is the same as multiplying by the reciprocal. I'm multiplying by 1/2. So that's what has to be in my equation. So y equals my ab to the x. Now, an important thing about your exponential functions, this b factor is what you multiply by, but it has to be positive. If it was negative, then your graph would go absolutely insane. It like zigzags all over the place. Oh, and my zigzags are getting deleted. Negative does not look exponential. It cannot be negative. And if it was 0, you just have the graph of a straight line. That's definitely not exponential either. So it has to be positive. All right, now that we have that refresher about what's going on with linear versus exponential, we're going to look at this notes page where we have growth and decay. And again, this is something you saw in Algebra 2, so I'm going to treat this as a refresher here. You're going to fill in this table on your notes. So if your b value is greater than 1, what that looks like with positive a is growth. You have a graph that's going up. Your default asymptote happens at y equals 0. Remember, that is the dotted line that you never cross. A is your y-intercept, like I said for the previous page. And then if you don't have any shifts, you'll have 1, ab. Now, if your b value is a fraction, remember it can't be negative, but if it's a small number, a fraction, then you will still have your default asymptote. You'll still have your y-intercept at a, but when you multiply by a small fraction, it gets smaller. So that is my decay situation. All right, let's fill this in on this table. So you filled in the top half already. I'm going to talk through the bottom half. Let's get that purple back. So I have my X and Y axis, my default asymptote that I never get crossed is at y equals 0. My y-intercept starts at A, but if A is negative, that means my graph goes here. So I have 0 comma A. Then if I do 1 comma A times B, and B is some positive number, that's going to be bigger, but positive times a negative is still negative. So negative growth is going down faster and faster. And again, don't cross the asymptote. Let's take a look at negative decay. For negative decay, my asymptote is in the same spot it always is. Negative A value means my intercept is down here, it's negative. But then if I have my A times B, where B is some fraction, it's going to cut A to be smaller for here. So 1A times B, I end up closer to the asymptote. And it flips this way. So your main things from this page are knowing these 4 shapes. Your standard positive A with a B that's greater than 1 is growth, positive A, B less than 1 is decay, negative A, B greater than 1 is swooping down, and negative A with B as a fraction is swooping up. But you never cross the asymptote. Now, from here, this is my base, but the equation can shift left to right. Here's what we got that you're copying in. Inside here, next to your x, it is the opposite, or your h is your opposite. X minus h feels like it wants to go left, but it's the opposite. X minus a number moves right, where x plus a number moves left. My k is a little bit easier. If it's plus a number, I move up. If it's minus a number, I move down. Now, the thing to know is that left-right shifts will not move an asymptote, right? If I grab, no, it won't let me grab that line. If I grab this line and move it left to right, and it's a line that goes forever, that doesn't change it. But if I have my asymptote and I try to grab it, and I shift up and down, that does move the asymptote. And we will test you on the equations of asymptotes. So let's look at what that looks like. I'm going to graph this function. I need to label the points, draw and label the asymptote, give the equation of the asymptote, and tell about the shifts. So first thing I'm going to do is just choose my 3 easiest points, which are generally going to be -1, 0, and 1. So to get my y value, I do 4 times 1/2 to the -1, 4 times 1/2 to the 0, 4 times 1/2 to the 1. If you know these in your head, that's fantastic. They're not that bad, but you can also put these in Desmos to see what's going on. Now, looking at this right away, I know my y-intercept should be at 4. It told me that from the start. And I know my 1 is A times B, so 4 times 1/2 is at 2. So I have these points, and it doesn't have any shifts left to right. I have none, and I have none. And I have a thing that's lagging. That puts my asymptote at the default position. When there are no shifts, the asymptote's at the default. My default asymptote, oops, sorry, the none and none was for my left, right, and up, down, which puts me at the default asymptote, which is y equals 0. And then if I take my 3 points and graph them, I do see that this is a positive a-value exponential decay. Now, with my domain on this is just like we did in the previous unit. I see that this one is going back forever towards negative infinity, and it's a connected line that goes forward forever towards positive infinity. So my domain is negative infinity to positive infinity. Or if you like set notation, it's x such that x is an element of the reals. My range, on the other hand, well, I see that my y values are going up. And what I want you to think about is if they ever touch 0. You should say no. With that asymptote, it never touches, so 0 is not included. Remember, not included means it's a parenthesis. So my start y to end y is going to be at 0 to infinity. All right, take a second to pause and see if you can give this one a try. All right, so you should have tried graphing number 2, and you'll end up with something like this. When you plug in 0, 1, negative 1, or 0, 1, and 2, you'll get some points, and this is all below the x-axis. You have no horizontal or vertical shifts, and your asymptote is at your default y equals 0. Domain goes positive infinity, negative infinity, because we have arrows both directions. But my range has a minimum at negative y as my start y, and a maximum at 0. Now, if you like set notation, you could also do this as y such that y is less than 0. Make sure it doesn't have the or equal there. So there's my base. And then I get into these where it starts shifting around. Now, we can graph this by hand with shifts and label 3 points, or we can use Desmos. However, you're going to have to know what is happening in words as well as using Desmos. So I'm going to pause and split my screen with Desmos. You pull up Desmos on your screen as well. All right, so I'm on Desmos, and I'm going to type the equation as I see it. Y equals 4 to the power of, now to get this x minus 1 in the power, you need to put it in parentheses on Desmos. If you try to do this without parentheses, Desmos will freak out and put that minus 1 on the regular layer, which is not where it should be. So on Desmos, because Desmos is not always the smartest, you need to put the power in parentheses. So let me make a note on that on the paper. You want to make a note of it on your paper too. It's going to be the tiniest toolbar ever. So, the power in parentheses on Desmos. All right, we're lagging again, so I won't write down the note, but put that power in parentheses on Desmos. Then what you're going to do is get coordinates from Desmos. So I have 0, negative 1 is one of my coordinates. Let me see what happens when x equals 1. That gives me 1, 1 as another coordinate. When x equals 2, that gives me 2, 5 as a coordinate. So I have an idea of what to write. Now, I still have to graph this accurately, which means I have to know more than just what Desmos says. So I have my 0, negative 1. I have my 1, 1. I have my 2, 5. But let me fill in this stuff before I connect those dots, because if I just connected that now, something will go wrong. So, looking at what's happening here. Inside with the x is opposite. So there was a shift by 1. It says minus. That means it was a shift to the right one. This word is supposed to say right, but it's lagging. So this is right 1. Minus 1 on the inside means right 1. Whereas this here means down 3. Minus 3 says it went down 3. Now that down 3 is super important because the up down is going to affect my asymptote. My default asymptote is at y equals 0, but it went down by 3. So now my asymptote is at y equals negative 3. 0 minus 3 is negative 3. So I need to put that dotted line here. And the reason why that's so important is because my graph gets close to that line, but never crosses it. If you draw this on your test and it crosses the asymptote, it is wrong and you lose points. You will also need to write the actual equation of the asymptote, so make sure you have that down. Now my domain, I have arrows going both ways forever, so it's still negative infinity to infinity. But my range starts at negative 3 and goes up, but we never include the asymptote. So that's a parenthesis situation. Negative 3 to infinity. All right, pause now. Try number 4 on your own. All right, so let's take a look. When we graph this, remember to put this in parentheses. If it's not in parentheses, Desmos will graph it wrong and your whole answer will be wrong. Once we have that, let me start by actually writing the shifts. With a +1 going opposite when it's on the inside, I know that means it will go left 1. Whereas a +2 on the outside means it will go up 2. That up 2 affects my asymptote. Y equals 0 is my default asymptote, but it moved up by 2. So y equals 2 is my new asymptote. Always draw on your asymptote. You don't get full credit if it's not there. From here, I know what the graph looks like, but I need 3 actual correct points. So I have a point at 0, 3. All right, I'll use black. 0, 3 is a point. Then let me see. If I'm at x equals 1, that's gross. So I don't want to graph 2.5. So let me go the other way. Oh, at -1, that's a way nicer point to graph. You need to have 3 nice points graphed and labeled. So if going one direction is getting you gross points, start going the other way. So now I can put these 0, 3, -1, 4, -2, 6. So I've used Desmos and my own knowledge to make a nice accurate graph. Notice that Desmos does not graph that horizontal asymptote. And to get full credit, you must graph that horizontal asymptote. So that is important. Now, my domain, as you may have noticed, for all exponentials, they go forward forever and backwards forever. It's always negative infinity to infinity. But my range, this time starts at +2 and goes up. Parenthesis on the 2 because it never touches 2 and going up. All right, so you will be asked to graph and you will be asked to write these things. If you don't know how to write those things, you're missing the main point. So make sure you know what those are. The last thing we'll ask you to do is take a look at some graphs and figure out which equation it has to go with based on your knowledge of shifts. So, first thing, draw and label the asymptote. This looks like it's getting super close here. So my asymptote is going to be at y equals 3. I'm just going to go ahead and label all of my asymptotes. This one is at y equals 0. All I'm looking for is where the graph gets flat and never crosses. Y equals -2. Y equals 4. Now, I can also figure out my domain and range pretty easily. First of all, every exponential ever has a domain from -infinity to infinity. There are arrows on both ends. Although these graphs don't show the arrows, they technically should be there. The range, once I have the asymptote, is not bad. The asymptote is either the starting number or the ending number. In this first graph, my y equals 3 is my low y, and I go up forever. So it goes 3 to infinity. In this graph, my y equals 4 is the high spot. So I start at -infinity and go up to 4. Remember, it always has to be the low y to the high y. You cannot reverse that order. It is not correct. So low y to highest y. Okay. I want you to fill in these last two yourself. Pause it. Try it. Hopefully you get 0 to infinity for number 2 and -2 to infinity for number 3. Now we need to use this information to match with equations. So if I am looking at a y-intercept, a y asymptote, a horizontal asymptote here that is up 3, I need an equation that has a shift up 3. So looking at my equations down here, C is possible, but it could also be none. Right away, I can eliminate A, D, B, and E when I'm talking about equation 1. Okay, so C went up 3. It went right 5. Well, the fact this is far over does make sense. And it has a growth factor of 2. So let me test this to make sure it works. Would 5, 4 work in this equation? So if y equals 4, and I put x as 5, okay, 2 to the 5 minus 5 power, 2 to the 0 is 1. All right, 5, 4 works in the equation. Does 6, 5 work in the equation? Sorry. 5 equals 2 to the 6 minus 5 plus 3. 5 equals 2 to the 1 plus 3. Yes. So equation C, it was up 3, and the points work. All right, so then let's look at this one. First, I notice it is decay. So decay means that my b value is less than 1. So right away, option C is out, option B is out, option D is out. Okay. Option E is out because its vertical shift was 0. So it's either option A or none of these. Oh, all right, let me plug in 0, 1. So in option A, if I plug in 0, 1, 1 for y, 0 for x. Now wait a second. 4 times 0 to the 1/2. 4 is equal to 1 does not work. So this is none of these. Points did not work in any of them. Try that same process with the last two. See if you can get which equation it is, or if it's none of these. All right, for number 3, you know it goes down 2, so it has to be B or none of these. If I plug in 0, 4, 4 equals 3 times 2 to the 0 plus 1 minus 2. All right, that is 3 times 2 minus 2. You just put that in Desmos. 6 minus 2 is indeed 4, so that first point works. If I put in the negative 1, 1 in Desmos as well, that should get me the same thing. So my points work. It is option B. Last but not least, if you're looking at equation 4, it went up 4 and it's decay. So up 4 and decay means it's not option C, it's not option B, it's not option E, it's not option A. Wait a minute, that's not decay. Don't get tricked. This is growth, so B is greater than 1, which means option D is a pretty good shot. So let's plug in 1, 1 and see if it works. Negative 3 plus 4, 1, 1 does work. Same thing in Desmos. If I plug in 2, right, I put that in, I would get negative 6 plus 4, which does work. So it's 4, it's growth, the points work. I'm at equation D. So this one is a little bit longer. However, you're going to see these graphs again in logarithmic form with the next section. So make sure you copy everything carefully, email your teachers if you have questions, and have a fantastic day.